Hi, I'm Mr. Franklin, and in this video, we will be talking about distance and velocity graph connections. We will also review slope and the slope point formula. So let's get into it. So one of the things that you saw in the last video, and I just kind of want to run through it again to make sure that you're clear on what's going on. We have a distance versus time graph. And so the dependent variable is distance, the independent variable is time, and we have the data table that goes with us that tells us the same thing. If we were to calculate the slope of this graph, it would turn into, we could then take that data and graph the velocity versus time. So if we took the slope at this point, which is 0, the slope at this point, which is 0, the slope at this point, the slope at this point, and the slope at this point, we could actually map that out down here at the bottom, and we would also get 0 all the way across, because this object is at rest. So in general, if we take the slope of a distance versus time graph, we're going to get a velocity versus time graph. Now, one thing I want to stress to you, and it makes sense when you see the gizmo, but sometimes we lose track of this in our thinking, is you got to think of this as this is time 0, and then time 1 second, the same thing is happening on both graphs. It's just this graph is going to talk about the distance traveled, and this graph is going to talk about how fast was it going, okay? So we're talking about the same object in the same amount of time, okay? But we're going to be looking at different parts of what's going on. So we're going to be looking at where is it at, as well as how fast it's going, okay? Sounds pretty simple. So here's another one, same thing, distance versus time. And it's going to take the slope of it, and we're going to arrive at the velocity versus time graph. Since this is a straight line, the slope never changes. So the slope here is rise 2 divided by 1, it's 2. So at 1 second, the slope is 2. At 2 seconds, we could do the rise as 4 divided by 2, and it's still 2, okay? So it's a straight line, so the slope is constant, so we could actually graph the slope of 2 all the way across. So when we do that, that tells us the velocity of this object is 2 meters per second. So time equals 0, okay? Time equals 1 second. So at 1 second, the object has traveled 2 meters. So we could see the starting line, and then the object has traveled 2 meters. Here, actually, let me sketch that real quick. So we have our starting line, and then 2 meters later, we have our object, okay? What that means, but it's also going 2 meters per second. So it's traveling with a velocity of 2 meters per second. So this graph talks about the distance it traveled, and this graph talks about how fast it's going over the same time interval. So that's pretty straightforward. It's going to be a not so straightforward, it kind of is, but not as straightforward when we get into acceleration, because now we're going to have different graphs, and they're going to have a lot more variation in what we get out of them. Okay, so in the last video, you saw slope is rise over run, and we just looked at the graph, and we went rise and wrote the number down. So in this case, it would be 8. And then we did run 4, and we wrote the number down, and it would be 4. So it's rise divided by run, and we've got 2 meters per second. Okay, pretty simple. And honestly, if you can just think of it that way, that's probably the simplest way to do most of our graphs. But I do want to show you another way to look at it, so that when things are not as simple, or you get stuck and it's like, okay, I don't understand what the rise over run is, this might help you. It also ties into your math class. So let's take a look at another way to look at this. And that would be the slope point formula. So in math, you've learned this. You've learned y2 minus y1 equals, our slope equals y2 minus y1 divided by x2 minus x1. And in a data table, this would be your x-axis, and this would be your y-axis, right? And then the 2 means the second point. Well, which second point? It doesn't really matter if it's a straight line. but we usually pick the last point as y2 and the very first point as y1. The important thing though is that whichever one you pick for 1 or 2 is that 2 comes further down in the table than 1. It has nothing to do with the size of the number. Okay, so y2 is the last one, and y1 for this class is going to be the first one. Could this one be y1? Absolutely. Why? Because it comes before y2. But in this class, we're going to keep it simple, and we are just going to do the first and last point 99.99% of the time. There's always an exception, right? Okay. In a previous video, we had talked about how X and Y is a generic case. It's just a general case that covers all situations, and it just really helps us understand the math. But now we've given the X a name. So the X now has a name of T, and the Y has a name of D for distance. So instead of y2 and y1, we are now going to do d2. So the y-axis is named d, so we're going to put that in here. So y2 becomes d2 because now that's the actual name of our y-axis. So distance minus distance, so distance 2 minus distance 1, divided by time 2 minus time 1. And we get distance divided by time. And if you know anything, if you remember from previous classes about velocity, velocity is distance divided by time. Okay, so this actually is going to be velocity. It's amazing. Okay, so now we're going to actually plug in our numbers. So let's do that. Let's plug in our numbers. So we plug in our numbers. We take the last point, D2, 8 meters. Notice that I put in the units minus 0 meters, and then 4 seconds minus 0. So there's the 4 and 0. So 8 minus 0 divided by 4 minus 0, we then do our math. 8 minus 0 is 8, so we could write down the 8. 4 minus 0 is 4. 8 divided by 4 equals 2. But notice, meters divided by seconds. I kept the units, meters divided by seconds. So 2 meters per second, that actually shows us that this is indeed a velocity. So now let's look at one with a negative slope. So same thing, rise over run. So we've got it's not a rise, it's a drop this time, right? So it's going to be negative. So drop of 40 and a run of 4. So negative 40 divided by 4, we should get negative 10. So right now you could do the rise over run. You can kind of check your answer, and that's great. It's awesome, okay? But let's take a look at this with the slope point formula. So once again, we are taking, it's a distance graph. If this was a velocity table, then this would not be D2, it would be V2 minus V1, okay? So you can put other letters in here. It's just, in this case, the name is distance, so we're gonna put distance. Start with D2. Now remember, we have to go with the last one. So the last one is 0. It doesn't quite make sense, but you put in the 0, okay? Especially if you didn't have the graph on a test and they just gave you the table. Most of you would just pick the biggest number, and that's not the right answer, okay? So you pick the last number, which goes here, okay? And then the first number, which is this one. So last minus first, last minus first, and then the same thing for the x-axis, time. So last minus first, last minus first. So we got 0 meters minus 40 meters divided by 4 seconds minus 0 seconds. So now we're going to do our math. And one thing that I've done since the 8th grade with math is anytime I see minus a number, I change it to plus and negative. Usually I put parentheses around it. There's just not room here. But 0 plus negative 40 is negative 40 divided by 4 minus 0, which is 4. Notice I'm using the units the whole time. So we've got meters divided by seconds, and then negative 40 divided by 4. is -10. And then I put my units, and that is the correct answer. Whew. Okay, so the really tricky thing with the negative one is making sure you're putting the numbers in the right order and just looking at the picture. Is it negative? Then yes, at the end, my answer should be negative. Always do that common sense check at the end, and you'll be pretty good to go. Okay, that wraps up this video. In the next video, we're actually going to talk about equations and solving math problems in physics. See you there.